Welcome to Arithmetic. Students watching, join us as we review our 7-division family. We're going to sit, stand, going back and forth through our entire family, starting with 0 divided by 7, seated together. Begin. 0 divided by 7 equals 0. 7 divided by 7 equals 1. 14 divided by 7 equals 2. 21 divided by 7 equals 3. 28 divided by 7 equals 4. 35 divided by 7 equals 5. 42 divided by 7 equals 6. 49 divided by 7 equals 7. 56 divided by 7 equals 8. 63 divided by 7 equals 9. 70 divided by 7 equals 10. 77 divided by 7 equals 11. 84 divided by 7 equals 12. Well done. As we finish up our family, we're going to do our multiplication facts, reviewing them together. So students watching, I'm listening for fast, accurate answers. Row 3, stand. We're starting with you.
63.
Good, Asa.
48.
Yes.
18.
Good.
70.
Yes.
36. 66.
You've got it. Students watching, how many were you able to get correct? Fantastic. Row 2, continue.
30.
You've got it, Arthur.
60.
60.
48.
Good.
24.
Yes.
12.
No.
18.
18.
26.
36. Arthur, I like that thinking. Students watching, how many did you get correct? Keep it up. Row 1, continue.
30.
You've got it, Kaden.
27.
That's it.
60.
Yes.
40.
Good.
12.
That's it.
72.
Well done.
77.
Good accuracy. Continue. Row 4.
9.
9 is right. 12.
16.
Good.
54.
Good, Anna.
24. 36. 35.
Good, Jackson. Students watching, how many have you gotten correct so far? Keep it up. Row 5, continue.
24.
Yes.
18.
Yes.
15.
You've got it.
24.
That's it.
20.
Yes.
42.
42.
84. 45. 21.
21. Way to think, Lexi and Dev. Students watching, were you able to keep up with that speed? Continue to practice that speed. As you become more confident with your facts, that speed will get better. Let's continue with division. This time we're starting with row 2. Row 2, stand.
8.
Good, Arthur.
9.
Yes.
6.
Good.
10.
Yes.
5.
Well done.
7.
Good, Arthur.
12.
12. Good. Row 3, continue. 2.
5.
Yes.
8.
8.
3.
That's it.
12.
12.
3.
3.
9.
9. Good.
7.
Good cadence. Good speed. Row 3, continue.
10.
Good.
3.
Yes.
10.
10.
4.
4 is right.
4.
4. Good. Row 4, continue.
11.
11.
6.
Yes.
6.
8. Morgan.
8.
8. Well done. Row 5.
5.
Good, Deb.
9.
Yes.
12.
12 is right.
13.
12 is right.
1.
1. Good. Students watching, how many did you get correct? Keep thinking. Good accuracy as you were practicing. Now let's listen through these longer rapid calculation practice combinations. When I say equal, you be ready to give me the answer. We're going to do girls' teams and boys' teams. Students watching, join your teams. 6 times 4 plus 4 divided by 7 equals girls. Cadence. 4 is right. 8 times 5 minus 5 divided by 7 equals boys. Josh. Jacob.
7.
Jackson.
5.
5 is correct. 8 times 2 plus 11 divided by 3 equals anyone. Asa. 9. Well done. 6 times 10 minus 10 plus 7 equals girls. Morgan.
57.
57 is right. 8 times 6 minus 12 divided by 6 equals boys. Students watching. Jimmy.
60.
Kaden.
6.
Girls. Cadence.
26.
Emily. Deb.
6.
6 is the correct answer. Fantastic. 8 times 1 minus 4 times 7 equals anyone. Asa. Jackson.
28.
28. 8 times 3 divided by 4 times 8 equals anyone. Adriana.
48.
48. Well done. Students watching, how many were you able to get correct? Way to work on that accuracy and speed. At this time, take out your speed drill materials. Your speed drill materials, we're going to be doing lesson 85. Speed drill positions, lesson 85. You'll have 3 minutes. You may begin.
Triangle.
Yes, what about this one? Jacob?
Pyramid.
Pyramid is correct. What about this one? Caden?
Parallelogram.
You've got it. Josh, what place is this on a shape?
Side.
A side. Good. Aiden?
Rhombus.
Good. Rhombus. Asa?
Square.
You've got it. Cadence? Count the number of sides.
Hexagon.
Hexagon is correct. What place is this on a shape? Gauge. Students watching? Kathleen?
Side.
Not a side, but you're thinking, Arthur.
Edge.
Not an edge. Emily?
Vertex.
A vertex is right. What do we call these two that come together at a 90-degree angle and they form almost a perfect square in that corner? What would that be? Carson?
Right.
A right angle is correct. What shape is this? Arthur?
Sphere.
A sphere is right. Good. And what place is this on a shape? Gauge?
Right.
An edge. Good. What shape is this? Morgan? Help her out, Deb.
Parallel lines.
Yes, these are parallel lines. Lines that run side by side or top to bottom, and they will never come and cross. We call that intersecting. These are parallel lines. Think about a railroad track. Those two lines run side by side. They will never cross or come together at an intersecting point. What shape is this, Jimmy?
Height.
Good. What shape is this, Anna?
Cube.
Good. What do we call this shape, Carly? Help her out, Una.
Cylinder.
It is a cylinder. What is it, Carly?
Cylinder.
Good. What do we call these two group of lines that do come together? Morgan? You could think of a road for this one. Carson?
Circling lines.
Very close. They are intersecting lines, but they are perpendicular lines. So these perpendicular lines come together where there are 4 right angles there in the middle. Not just any two lines that cross, but they come together and cross at right angles. What shape is this, Adriana?
Cone.
A cone. And what do we call this place on a shape, Carson?
A face.
A face. Good. What shape or what do we call this, Una?
Rectangular prism.
A rectangular prism is correct. Now we're going to think through some more types of measures. So let's take a look here at the chart. These are measures of weight. We're trying to find out how heavy something is. So when we're looking at a measure of weight, trying to find out how heavy something is, we're looking for these units. These can tell us how heavy something is. Now we both have the English and the metric. Let's read 1 pound together. Begin. 1 pound equals 16 ounces. 1 ton equals 2,000 pounds. 1 kilogram equals 1,000 grams. And down at the box at the bottom with remember, give me the abbreviation for pound. Carson.
OB period.
Good. Give me the abbreviation for ounce. Una.
OZ period.
Good. Give me the abbreviation for ton. Caden.
T period.
Good. Kilogram. Josh.
K.
KG with no period. Give me the abbreviation for gram. Arthur. Just the letter G. Well done. Now, as we continue reviewing some of the things we've already talked about, we're now going to think through several types of Roman numerals. I have some popsicle sticks that we're going to use. I would like row 4 come to be ready to help me out here on this side. These popsicle sticks are going to represent our Roman numerals. So we're going to form different groups. Gage, hold 1 for us. And if Gage were holding just one popsicle stick to represent one of these letters, which represents a number, an Arabic number, what would the Roman numeral be representing for the Arabic number or value? Kaden?
1.
1, exactly correct. Thank you, Gage. You may return yours, and you may place it over here, and you may return to your seat. Now, you can place yours side by side, Morgan, and Morgan has what number? Madison?
2.
Good. Now, if I were to give Jackson some, thank you, Morgan, you can set yours down and be seated. Place those side by side. What number did I give Jackson? Asa?
3.
Yes, exactly correct. Now, Presley, make a V for us. You can slide towards the middle. And Presley has what number? Cadence?
5.
5, good. Thank you. Set yours down. Make an X for us, Jimmy. And as Jimmy makes his X, what number does he have, Josh?
10.
Now stay there. Anna is standing beside him. What number do I now have, Adriana?
1.
Good. So I have an X, which represents 10, and I, which represents 1. If we have a large and then a small, am I adding or subtracting, Una?
Subtract. Adding.
Adding. So what number is this, Una?
11.
11. Now stay, but Anna stand on the other side of Jimmy, and she's switching sides. Now we have the smaller and then the larger. What process am I going to do, add or subtract, Madison?
Subtract.
Good. So what number do I have now, Arthur? If we're subtracting 1 from 10, what number is it now?
4.
Not 4. 10 minus 1 is?
9.
9. Thank you, helpers, with my popsicle sticks. You may return those to our table at this side. We're going to continue thinking through some types of fractions. When I say a fraction, we're thinking an equal part of a whole. A fraction is an equal part of a whole. So I want you to tell me the fraction that you see here. What is this fraction, Una?
1/2.
1/2. And we know that we have one of the two parts that is shaded in, so that is the fraction 1/2. Let's take a look at this one. What fraction do you see here, Jackson?
A 6.
Yes, it is 1/6. One part of those, not 6, count again. You're very close.
7.
Yes, 1/7. It is one of those 7 parts that are shaded in. So this is the fraction 1/7. Now, as we take a look at this number, which one is the numerator? Josh?
The 7.
No. The 1. Which one is the denominator? Kaden?
The 7.
Yes, the 7, which is the number that belongs underneath or down. Let's take a look at this fraction. What is this one, Adriana?
1/3.
Yes, 1/3. As we look at it, give me the denominator, Presley.
3.
3. Good. Let's take a look at this fraction. Give it to us, Madison.
1/4.
Good. Give me the denominator, Aiden.
1.
No.
4.
4 is the denominator. What is this fraction, students watching? And Asa,
5.
give me the whole fraction.
1/5.
Stand and say it nice and loud.
1/5.
Now there are 5 parts, but it will read as what, Asa?
1/5.
1/5. Give me the denominator, Kathleen. Give me the number that's in the denominator. Is it the 1 or the 5?
No.
It is the 5. Remember, denominator goes down. Give me this fraction, Carson.
1/8.
Good. Give me the denominator, students watching. And Arthur.
8.
8 is the correct answer. That is the number that goes down. So the 8 is the denominator in those fractions. As we take a look more at fractions, we're going to take a look at our chart right here. Our chart here is going to show us several things that have to do with fractions. But remember, a fraction is an equal part of a whole. So when I say fraction, you need to start thinking equal parts of the whole. Now here on the side, I have the 1 that's labeled as my numerator. That's the number that goes on top. The 2 down here is my denominator. So the numerator is the number above. The denominator is the one that goes down. Take a look at these circles here. They have been all divided into 5 parts. So each fraction has 5 parts, but a different color or a different number of those parts have been shaded in. Here we have one of those parts shaded in. Here we have two of those parts shaded in. Here we have three of the parts shaded in. Here we have four of the parts shaded in. And here we have all 5 parts shaded in. And you'll recognize that if I did that, that means the entire thing would be shaded in. Now these numbers underneath show us the parts of the whole. This is 1 of the 5 parts, 2 of the 5 parts, 3 of the 5 parts, 4 of the 5 parts, 5 or all of the 5 parts, which would be the entire circle shaded in. We're going to compare them and find out which is larger. Let's take a look at this small orange here, this tangerine. My dad grows these, and so we have plenty of them around. And I have taken it, and it has been divided into several parts. If I were going to divide this and say I would like to share 3, and let's say we had 3 of 5 parts, and I were going to share 3 of my 5 parts with someone. Let's say I was going to share one with Cadence. You may come get one of these. And then Carly, you can come get one of these. And let's have Jackson come get one of these as well. So I shared with them 3 of the 5 parts that I had for my tangerine here. Now that would be the number 3/5. Which one would be a larger amount to share? What if I only shared 1 of those 5 parts? That is a much smaller amount than sharing 3 of the 5 parts. If I shared all of those, that number shows us that it's larger. So the shaded in area shows us that is the larger area. So 3/5 would be a larger amount than the 1/5, which would be that smaller amount. So when the numbers are the same, or when the denominator is the same, you can equally compare the numerators. Here you see 3 of the bottom pieces of fruit down here are oranges. Now let's take a look at these 2 candy bars at the top. We're going to compare something different. This time, we're going to compare the denominators. Here we're going to take this, and this is going to represent a chocolate candy bar. And we have 2 chocolate candy bars, but we're going to divide them up into different groups. The first one we're going to divide into 5 parts. And I want you to take a look at the numbers. Well, we know that 5 and 8, normally if I were to say which one's larger, we would all say, well, obviously the 8 is larger. But is that actually the larger piece? Let's take a look. So the first candy bar, we're going to divide into 5 parts. So I'm going to draw lines. 1, 2, 3, 4, and 5. So if I were going to set that up into 5 parts and then have one of them that I could share with someone, that is the size of one of those 5 parts. But now for the next candy bar, we're going to take it and we're going to divide it up into 8 parts. So watch as I divide into 8 parts. I'll do it this way. So now we have 4, and when we divide it up into 8 parts, the parts become much smaller. So watch this. When I shade in one of those 8 parts, do you see it is much smaller than one of those 5 parts? So which is actually the larger fraction, Josh?
That 1/5.
The 1/5 is correct. So if the denominators are different, you can't just go with a larger number because the pieces then will be smaller. So when you're comparing fractions, the smaller denominator is actually the larger size. So when you're thinking through those fractions and we need to compare them, look at that denominator. The number that's smaller will be the larger size. So think carefully through that. I'm going to show you a couple of these fraction cards here, and we're going to take a look at this here. Here, I have 4 of the 6 pieces shaded in. Let's compare it with 3 of the 6 pieces shaded in. Well, obviously, since the numbers at the bottom are the same, we can just compare the numerators. And the number 4 is the larger one. So that's what we're going to do when we take a look at these fractions. We're going to put them in order. So I'm going to have some helpers. So let's have row 2 come and help me out, and Dev and Amaya. So you can come, and for right now, go ahead and just stand where you come to the front, and then we'll go ahead and put you in order. All right, so let's see. Which fraction should be the one that is first? Students watching? And Asa. Which one would be the smallest piece? All the denominators are the same, so we can just compare numerators. Which one is the smallest number? Caden? Josh?
Aiden's.
No. Yes, Aiden's number, which is 1-6. So he's in the right place. Which number would come next, Jimmy?
Yuna's.
Yes, so Yuna, go stand beside Aiden, and boys slide down. So now we have 1-6, then 2-6. Because this 6 is the same, we just compare the numerators. We have 1-6, then 2-6. Which one? So Amaya, you can slide by Yuna, and boys slide toward me. So now we have Amaya's fraction, which is what fraction, students watching? And Jackson. What is Amaya's fraction?
3, 6.
Yes, 3-6. Good. Which one would come next, Jimmy?
Dev.
Dev. So Dev, you may go stand. Next, what is Dev's fraction, Asa?
3.
Not 3. Count again.
4.
4 what?
4 fifths.
No, not fifth. Caden? What number is at the bottom? How many pieces are there in all? Josh?
4.
Students watching? Anna?
6.
Yes, there's 6. It's not going to change. So it's 4, 6. What is the next number that would be the next largest, Morgan?
Arthur.
Arthur's, which is what number? What is his fraction?
5.
5, 6. And then which one would be the largest, Madison?
1 whole.
Yes, 1 whole, which is 6 of the 6 parts or pieces that have been shaded in. Thank you, helpers. Now let's just say their fractions. So I'm going to tap them. Helpers, you hold your cards nice and high for us so that we can see them, and then keep them nice and still. We're going to start with Aiden, starting at 1, 6. Ready? Begin. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, which is 1 whole. Thank you, helpers. You may set your cards down on our table and return to your seats. So when we take a look at fractions, we're thinking a part of an entire whole. If the denominator is the same, then we can compare the numerators to find the larger. But if the denominator is not the same, we pick or choose the smaller denominator because that is the larger size or the larger piece. Go ahead and take out your arithmetic page, write your name at the top, arithmetic page, and then you can write your name there at the top. Let's take a look at that box, comparing fractions. When fractions have the same denominator, the fraction with the largest numerator is the largest fraction. 2 fifths, 3 fifths, 4 fifths. But when the numerator of the fraction is 1, it is called a unit fraction. You can circle the words unit fraction. The unit fraction with the smallest denominator is the largest fraction, like we talked about together. Number 1, write these fractions in order from smallest to largest. Before we begin, I want you to take a look at the denominator. Is the denominator the same, yes or no, students watching? And Anna?
Yes.
Yes, so we just need to line them up in order from the smallest number in the numerator to the largest. Go ahead and write those carefully. Not every number is used. So think about which numbers there are and then put them in order. Once you've used that fraction, you can put a small check beside it or cross it off so that you remember that you've used it, and then go and find the next largest. Good, you found it. Good, Morgan. Good, yes. Yes, I like how you figured it out. Good, Jimmy. Yes, that's it. Now you're just looking at the numerators. So which one would be the smallest? 3, 7, 1, 5, 4, and 9. It's like the normal smallest number. Let's begin checking these fractions. Which one would be the smallest, Cadence?
9, 10.
Not 9, 10. That would actually be the largest. Give me the smallest, Adriana.
1/10.
1/10. Give me the next largest. Arthur.
3/10.
3/10. After that, Carson.
4/10.
After 4/10, Una.
5/10.
After 5/10, Josh.
7/10.
Good. After 7/10, Caden.
9/10.
You've got it. Now for section 2, you're going to write these unit fractions in order from smallest to largest. Look at the numerator. The numerators are all 1. So now we're looking at the denominator and comparing the denominator. Remember, the smaller the denominator, the larger the piece, just with our chocolate candy bars. So which one then would be the smallest piece? Morgan?
1 second.
Not 1 second. Carly?
1/2.
Not 1/2. Caden?
1/12.
1/12. Imagine having to share one candy bar with 12 people. That would be a very tiny piece. So 1/12 is the smallest, which would be the next largest. Presley?
1/8.
1/8. You're still sharing that piece of chocolate with several people, so that piece is pretty small, which would be the next size. Carson?
1/6.
1/6. Then after that, Asa?